A couple other people there.
Hello everyone, and welcome to the second part of our 5-part webinar series on Toyota's TIPROS FMS software. The series is meant to keep these concepts fresh in your mind, as well as explore new functionality for your FMS system. Today we're going to focus on what we consider the core concepts of running the FMS cell, and our intent is that covering these concepts will help you properly set up the TIPROS FMS system data. What we'll be covering today includes tooling manuals, naming conventions, pallet types, workflow, and we'll also touch on program format. As for introductions, for those of you who were not with us last time, my name is Tim Campbell, and I'll be administering and presenting the webinar series. I'm part of the marketing team here at Toyota. Joining me here today is Keith Jackson. I'll let him introduce himself just briefly.
Keith Jackson, Toyota application engineer.
And he'll be our technical advisor for the series, helping me answer any questions that you may have. All right, so we're going to start this off with a poll. A majority of what we'll be focusing on is proper setup, so we'd like some feedback regarding your own system. So question we have here is, do you know how to check your system's spindle utilization? You'll see a poll launch in a second here. And just go ahead and indicate yes or no. We'll leave that open here for a few more seconds. And if you don't have a system, just go ahead and leave that blank. That's fine. All right, so here are the results for that poll. Most of you actually do know how to check the spindle utilization, which is great. And for those of you who do not, we can address that here at the end. Our next question is for those of you that do know, please go ahead and indicate the range that your utilization falls into. So that'll launch here for you a second. Go ahead and indicate 70 to 80, 80 to 90, 90 plus, or if you don't know, if you don't have one, please indicate not applicable. All right, so we're going to close that and share the results with you. So majority answered not applicable. Some did say under 70%. And of course, the purpose of this webinar series is to ensure that you can increase that utilization to get the most out of your system. Some of you did say 90 plus, which is fantastic. Okay, and again, we will have time at the end to answer any questions, and we can help you figure out the best way to get the most out of your system. Okay, so as I said, this episode will focus on the key concepts, or what we like to call the building blocks of the FMS cell. I should be able to answer the following question: what is your system capable of doing? Our goal is that by the end of this episode, everyone will know how the system will be set and what can be accomplished. And as I said before, if there's something that you still have a question on, we'll have some time at the end to answer questions. If you note the slide number at the bottom of the screen, we can address that and go back at the end. So first, we're going to move into the topic of understanding the specifications of the system, which are defined in the tooling manuals. So when we refer to the tooling manual, we'll focus on 4 areas. That would be machine capacity, machine travel, tooling specifications, and spindle specifications. Now, each system will be unique, so it'll be based on the machine size. If you do need any help understanding your own, please let us know. So before we do get started, let's look at an example of our naming conventions, since some of this information is in the name of the machine itself. As an example, we have the FH630SXI. FH would be the name of the machine series, 630 is the name or the size of the pallet in millimeters square, and then SXI is the model. As for pallets, pallets of all sizes will have their own specifications that do need to be followed. Weight will be important, of course, but where you place the weight on the pallet is just as important. Height of the base or tombstone will also determine common offsets, which will vary by machine size. We'll discuss fixture and base information later on. We have some images from the 630SX tooling manual to give you an idea of what we're talking about. One aspect of the machine stays constant, and that would be the height of the pallet from the floor. This allows multiple generations of a certain machine size to work together in the same cell. This gives Toyota systems a huge advantage as you're able to add more machines over time as your workload increases. So here you see we have more information about the 630SX. Okay, machine travel describes the area covered in all axes from the home position. This is important to keep in mind when you're programming a new part or setting up a tombstone that a fixture needs to be mounted to. Here we have some examples from the tooling manuals of the 500J. This would be the 630SXI. And finally, we have the FH800SXI. As I said before, the spindle has its own specifications that need to be kept in mind. This includes the tools as well as the weight and length of the tool. Each will have an impact on your efficiency as well as machine cycle time. The finish of the part is also impacted. So again, each spindle is unique. Things like max RPM, the power curve, and torque must be determined before machining a part. These will all play a role in the life of the spindle as well as life of the tool. Now we'll be moving on to the important topic of naming conventions. We'll talk about how to name individual programs, tools, fixtures, or base in the cell system. It's also important to keep in mind why we have these conventions in place. These names can be customized per system, but you should try and make them consistent. We'll get started with how we name programs or parts. So in this graphic here, you'll see an example of our naming convention for the program being run. The part can have a name containing up to 46 characters. In red, we have the part name that could come off of a print. Operation number is indicated in yellow, and the process number is there in pink. Dashes will separate the part number, operation, and process. So again, red indicates the part name or program that will be used to machine this part, which can be alphanumeric. The yellow one indicates that this is the first operation for the part, and each part can have a maximum of 7 operations within the cell. Finally, the pink 1 lets us know that this is the first process. The process determines when the part is loaded into the machine and cut. It's important to keep the part names accurate, as that's what we'll use to program the cell. Remember, this program is then able to be run in any machine in the cell as long as the required tool is available. So as an example, here we have a part with 2 operations and 2 processes. So in the first example, this would be the first operation for a part. An example might be a part that's clamped to a fixture using toe clamps. You then go ahead and drill holes for screws to then hold the part to the fixture in a separate process. Building on that, the second example, this would be the first operation of the second process for that part. The part would come out of the machine. The same screws that we had just drilled are used to then hold that to the fixture, and we'll remove the toe clamps to go back into the machine to be machined again. Now please note that this part cannot be removed from the fixture. That would mean something else. Third example, this is the second operation and the first process. So this would come out of the machine and it's ready for its second operation. You can unload it and then load it back onto a new fixture, and then it's ready for its second operation. Tool naming conventions should be put into place before you even start to program parts into the cell. For example, you can name tools as number 1, 2, or 3, and so on until you ran out of pocket numbers. But instead, why not use this system to give tools a unique name so that you can track the tools throughout the cell? Now the name has, in this case, a distinct meaning and can be found easily when you need to set a new part. So on this screen, we actually have an example of a customer's tool naming chart. The T callout on the left is constant and will not change. Location 1 there, where it says tool identification, will indicate the type of tool to be used. So for example, we have face mill, tap, center drill, and so on. Location 2 designates the material of the tool to be used, whether it be carbide, high-speed steel, cobalt, PCD, and so on. Locations 3 through 5 represent the diameter of the tool, and location 6 would let us know if there are duplicates of a certain type of tool in case of backup. So for example, if the tool had a diameter of 1/4 of an inch, the proper call out would be 0 to 5. If the tool diameter were 1.5 inches, the call out would be 150. So 0 would be in place in front of any tool smaller than 1 inch. The tool listed in the example at the bottom here would be a 1.5 inch diameter carbide inserted end mill. You can have as many as 8 digits in the tool management system, so you're able to customize this as necessary. And again, as I said, it's best to just make an example so then you can follow this throughout the cell. Okay, next we'll cover fixture naming. By naming the fixture, you're able to relate an individual part to a specific fixture position. Fixtures will have their own specifications just like each machine, so you'll need to be aware of variables like work offsets. You're able to have more than one part mounted to each fixture, and each fixture has location that it should always be mounted to. And again, this is just a simple example of how the fixture should be named. We have the fixture in green as 343245OP10, which is a specific name assigned to that fixture. While each fixture name must be unique, there also, you notice, is an A or B at the end to indicate duplicates. Duplicates would then be listed as A to Z. We're going to build on the part naming example that we had earlier and name a fixture which includes the operation. So in red we have the part name, OP10 would be the operation, and A references that this is the first fixture made for that part. The same fixture name would be used for a duplicate, but then of course the group name would change from A to B. Now the base is what your fixtures are mounted to, commonly called tombstones. Naming the base is similar to naming a fixture, and each base should have its own unique name, such as what we have here as 6x6 square A. This tells me that I have a 6x6 square base, which is the first of its kind in a system. Again, 6x6 square B would be the second. Naming the base as such allows you to put different base on the same pallets. So before we move into our next topic of pallet types, we'd like to have one last poll here of the different pallets that you use in your system. Now 4 are standard, but again, we just like to get a better idea of what you have. So that will launch here in a moment. And go ahead and indicate if you use one work, plural, 4-face, one work, or 4-face. And there will be a second part here in just a moment. All right, so we see that a majority of you have been using the one workpiece, and we do have some dispersion among the others. Next, we'll be moving on to the second part of that poll, where we have other types of pallets as well. So again, go ahead and indicate if any of those are used in your system. So as you see here, which likely isn't a surprise, changeable fixture was the most common that we saw, with 58% of you answering that that is what you are using. All right, so we're going to talk about the different pallet types that are used in the FMS. We did have 8 listed here, but we're going to talk about the 4 standard types. The 4 additional are options, but they tend to be a little bit less common. If you would like to learn more about them, we can talk about that at the end of our session. The different components are color-coded so we can see the difference between workpiece, fixture, pallet, and so on. Okay, so our first is the type 1 single workpiece. Very simple, only one part is on the pallet at a given time, and it can be anywhere on the pallet. Type 3 is called 4-face with one workpiece. It allows for 4 different parts to be mounted on the pallet, with each occupying a different work area. Next, we have our type 7. This is the changeable fixture, which most of you reported that you do use. It supports up to 20 different fixtures and up to 40 workpieces of different part numbers. So it allows for an unlimited number of product types as long as the total number of workpieces is under 40. The fourth of our standard types is type 8, and this is the changeable base. So it works very much like the changeable fixture pallet. So instead of swapping out the fixtures, you just change the bases or tombstones so that you can track any of the bases as you take them off the pallet. Much like I mentioned before, we do have 4 additional types, so if you'd like more information on that, please go ahead and let us know. All right, so we're going to switch gears at this point and discuss the workflow or work data within the TIPROS FMS system. Workflow is how a part or pallet is routed through the cell. Now this depends on your system configuration, so it can depend on the number of machines, number of operations, or if you have auxiliary stations like a wash booth. There can be a maximum of 7 operations and 10 processes on a part that is in the system. If the part is taken out of the cell and other operations are performed, this part will then have a different name when it is reintroduced to the system. And here on this slide, we have a quick idea of how the part flows through the system. So at the bottom left, we have our load station. It then enters the cell onto the RGV. We'll send that to the rack. It'll be on the pallet buffer stations. and we send the RGV back to pick up the pallet, which is then sent to the machine when it's available. Machining is completed, and it's taken by the RGV from the machine back to the load station for your operator to take it out and load in a new part. All right, and as I mentioned, we will touch on program format here briefly. The standard Toyota program format will work on both level 1 and level 2 software, with the only exception being how the cell controller will handle the subprograms and work offsets on level 2. So if you were in our first webinar session, you'll recall our discussion about cell controller software. So level 1 runs all the programs from the machine's CNC controller, while level 2 and above will run the program that is downloaded from the cell controller. We can go into much greater depth regarding the program format, but we can save that for later, depending on our time. So, in summary, that does wrap up our second episode on software. I hope that was informative for you, and you're able to learn a little bit more about your system and how to use it properly. We spoke about the different tooling manuals that are used, demonstrated common work offsets, and went into detail about different pallet sizes. We showed you how to optimize workflow, explained Toyota's naming conventions, and then finally discussed program formats such as probing cycles and setting up subprograms. At this time, we will take any questions. That's all we have for you. I know that was a lot of information thrown at you in a quick amount of time, so we do encourage any feedback or questions. We do our best to tailor the series to you, so again, that feedback is always appreciated. I'll leave a few moments here for any questions that we do have. And I do invite you all back for our next episode, which will go into greater depth on the cell controller, the brain of the cell. And that episode will premiere on November 3rd, again at noon Central. And all of you will be receiving an invitation to register for that as well. So at this time, we'll wait for any questions that you may have. Those are always welcome. All right, so we do have some questions coming in here. We're going to have Keith handle that, and I'll just go ahead and moderate. So one of the questions is simulation still available to calculate production quantities and mix?
Yes, it is. But you got to get in contact with our proposal department, and they can give you those numbers.
Okay, so if we go ahead and get in contact with proposals, we'll get that handled for you. All right. Another question, Keith, was how do we check spindle utilization?
Well, it's kind of difficult to describe now, but it's under what we call reports, and there you got spindle. It's not spindle utilization, but there's a report that tells you this. So I need the cell controller to really show you that at this time.
Okay, so there is a report to go in and check spindle utilization. We will be logging into our cell controller live at our next session, going through the different reports, and we can show you how to do all of these different functions.
Right.
And then we have another question about the max number of processes. Is the max number of processes 7 or 10?
Well, it's operational processes.
Okay.
Which one does he need to?
So what's the max number of operations and what's the max number of processes?
The maximum number of operations is 7. within the cell and 10 processes.
Right. So 10 processes and then 7 operations.
Yes.
Okay. So I hope that was able to answer the questions that we all had. We will stay for a few more minutes and just see if anybody does have any remaining questions. All right, that does seem to be all the questions we do have for today. If you do think of anything in the future, or if you watch the webinar later and something does come up, please send that in to us. As you see here, we do have our contact number, so that's 800-257-2985. Or you can always send an email to service@toyota.com. I do invite you all to attend our next session, which I said is going to be on November 3rd at noon Central Time. We will be logging into our cell controller live, and as I said, we'll show you all the different functions and how to pull reports that can be used to aid in your production. Thank you all for joining us here today, and we look forward to seeing you at our next session, which covers the cell controller. Thank you.